A very great pleasure to be able to introduce the Deputy Director of the Institute, David Vaux, who really needs no introduction. Not only did David do some of the most seminal work that's been done here in the last 30 years on cell death, really starting that field at the Institute in the late 80s, but as you would all know, he has an absolute passion for scientific integrity and probably gets asked to speak on that topic internationally more than his science. And we're delighted that, as much as his science, and we're delighted that he will talk to us today about the Institute's policy and practices around scientific integrity. Dave.
Thanks, Doug. This is a new thing, you know, for an old-timer like me to clap at the start of seminars, because in my day, nobody would clap at the start because you didn't know what you're in for. So this isn't my usual 10 rules talk, so this is going to be something slightly different. I'm going to be concentrating mainly on two aspects that people have talked to me about recently, and one is policies to do with authorship and who should be an author and who shouldn't be an author. And the other policy is to do with how WEHI handles allegations of scientific misconduct. So all of you can find WEHI's policies by looking on WEHI's open website or on looking through the intranet. The aim of the policy is to prevent authorship disputes and research misconduct, but to operate on the assumption that they will occur. I was at the world's third World Conference on Research Integrity in Montreal, and there one of the panel members said that she would never join a university that hadn't sacked someone for research misconduct, because if they haven't done that, then they're not doing a good enough job. So integrity means consistent adherence to moral and ethical principles. And some background and a sort of overarching statement and some ideas can be seen if you download the Singapore statement, and there's also a link to that on the WEHI website. In promoting research integrity, there are two key responsibilities. There's maintaining and improving the quality of the research literature by minimising entry of errors before publication and by detecting and correcting errors after publication. So this is the integrity of the scientific record, its freedom from errors. And the other aspect is the integrity of researchers themselves. So fostering the practice of science as a fair process in which credit is attributed appropriately, regulations are followed, and those who are unsafe, dishonest or cheat the system are caught and penalised. And that way people will have confidence. There's plenty of room down the front. I'll use my laser beam on I've got the bright one. You know, there's plenty of seats down the front. Office of Health and Safety Regulations won't permit that. Some issues, such as fabrication of data, relate to both of these responsibilities. So if you make up data, then it's obviously going to put errors in the scientific record, and it's also cheating the system, whereas others, such as plagiarism or failure to adhere to guidelines or regulations, might not introduce errors into the literature, but it's still something that needs to be prevented if possible and corrected when it does occur. So, integrity of the scientific record is preventing and correcting errors in the scientific literature. Errors can be accidental, and the great majority of errors in the literature, I believe, are accidental. You know, if you look at John Ioannidis' conclusions published in PLOS Medicine, he concluded that more than 50% of research findings are false. And if you look at Glenn Begley's study published in Nature, he said that 90% of landmark papers, the results can't be reproduced. Now, this is mainly due to accidents, bad luck, sloppiness, poor experimental practices. 1 in 20 results will be statistically significant even if there's no result. Many papers are not read or reviewed carefully, even by the authors. These things are not usually classed as research misconduct. But these errors still need to be corrected, and if found, there is a responsibility to correct them. Just to give an example, here's a paper published recently in Genes and Development. You'll see in this figure there's plenty of error bars, and you have to come to my other talk to hear about error bars and what they are. But everybody should know that if you show error bars, you should say what they are in the figure legends. But in this paper, it doesn't say what any of the error bars are in this figure or in any of the other figures, and it doesn't say in the materials and methods. So it makes me suspect that this paper hasn't been carefully read by the authors, because I can't believe that Craig Thompson, the president of the Memorial Sloan Kettering Institute, and Scott Lowe, who used to be an assistant director at Cold Spring Harbour and is now at Memorial Sloan Kettering, I can't believe that they don't know what error bars are. So it makes me suspect that maybe they haven't read the paper carefully, and indeed perhaps the reviewers and editors haven't read the paper carefully. But this is obviously not scientific misconduct. Nobody would intentionally pretend to be incompetent. Integrity of the scientific record is preventing and correcting errors in the scientific literature, as I've said, and errors can also be deliberate. That is due to falsification or fabrication of data. And this is, unlike the other, is classed as research misconduct. This is an example from somewhere in Australia, and I'd like you to look at the top panel up here, and I'll change the contrast so you can see some abnormality. Could you make some comments about these two parts of the figure there? Anything look suspicious to you? It seems to be identical. In fact, both of these panels seem to be absolutely identical, and those with really sharp vision will notice that these parts here are actually mirror images up the top, but that's very hard to see. This is a figure from another part of the paper, and if we could change contrast here, you can also see some cuts and apparent splices as you do up here. And if you expand that, it might be easy to see some of the similarities, and then you expand that one, and then you take this one up the top and you turn it round and you compare it down below, you'll notice that this band here is really the same as that one there, as well as that one there. Now, this was reported to the journals. It was reported to the institution. There were 3 institutional investigations. The first 2 found that there was nothing wrong. The third one found that there was not only things were wrong, they also found that the person who was they thought was responsible had been untruthful to the investigating panel. Nevertheless, they found that there were no penalties to be had. They just asked that the paper was corrected. Here's the correction in Journal of Biological Chemistry, and you can see here they've just faked a new, yet another panel. So again, there's no, so here's another example. This one's, some of you may recognise this particular molecule up here. This is showing that in the control there's no tunnel staining. There's tunnel staining with this drug, and with an inactive form of the drug there's no tunnel staining. If you, this was a PowerPoint slide. If you uncrop the slide, you can see here this part is cropped from a large image. This one is also cropped from a larger image, and so is this one over here. But if you look here, this is the same image as this one over here. So they've just, as the positive control, they've taken this part, and as the negative control, they've taken this part. This file was part of a file that was involved in an investigation that found that there was no misconduct. And that wasn't because I believe they came to the wrong conclusion, but the problem was the investigating panel didn't have experience in how to look forensically at images and how to deconstruct them. So it's not possible to determine if errors are accidental or deliberate, or determine who is responsible without conducting an investigation. And so the latter part of this talk will be talking about the procedures we have at the Walter and Eliza Hall Institute to do that. Whether errors are due to misconduct or not, even if they're accidental, they still should be corrected. So the other aspect is, so that was referring to integrity of the scientific record. The other aspect is integrity of researchers, and that refers to adhering to the rules, conventions and norms, and following the rules and regulations for experiments involving humans and animals, declaring funding sources and conflicts of interest, properly attributing credit by authorship and acknowledgement. And so some breaches of researcher integrity, such as fabrication and falsification, can cause errors in the literature, but some do not. In either case, to maintain confidence in the research enterprise, misconduct should not be tolerated. So I'm not going to go through all of the stuff in WEHI's guidelines, but I'm going to focus in particular for this talk on authorship and our procedures. So authorship. This is from a piece published in PNAS back in 1989 on being a scientist, and so there were a lot of big guys who gave their opinions on authorship and allocation of credit. Fraud may be the gravest sin in science, but transgressions that involve the allocation of credit and responsibility also distort the internal workings of the profession. In the standard scientific paper, credit is explicitly acknowledged in two places, at the beginning in the list of authors and at the end in the list of references or citations, and sometimes accompanied by acknowledgements. Right, so this is 1989. And this is further on in the same article in PNAS. The division of credit can be particularly sensitive when it involves postdoctoral, graduate or undergraduate students on the one hand and faculty sponsors on the other, and that's because there's a difference in the power relationship. In this situation, different roles and status compound the difficulties in according recognition. If a senior researcher has defined and put a project into motion and a junior researcher is invited to join in, major credit may go to the senior researcher even if at the moment of discovery the senior researcher is not present. Similarly, when a student or research assistant is making an intellectual contribution to a research project, that contribution deserves to be recognised. They also talk about plagiarism. Plagiarism is unacknowledged use of techniques, data or ideas of another, right? So it's not just words, but it's also idea, intellectual property. They say that it's best to err on the side of excess generosity in attribution. So that goes not only for authorship, but also in the acknowledgements and also in the citations to other researchers. They say that the intentional use of another's intellectual property without giving credit may seem more blameworthy than the actions of a person who claims to have plagiarised because of inattention or sloppiness, but as in the case of fraud, the harm to the victim is the same regardless of the intention. And so I've mentioned that before. So here's a quote from a senior WEHI researcher, a number of quotes. And again, this is to put our current policy into context and to try to explain where it's come from. But please note that our policy, as outlined, is not static. And if people do have good ideas for improving it, then that will be done. There is fairly general agreement that a person should not appear as a co-author who has not done any of the actual experiments. Now, some people would agree with that. Some people would say that nowadays, because teams are big and because the PIs and lab heads sit in the office all day, many papers are written in which the leader of the team has not done any of the actual experiments. It is my view, not held by some people, that division heads should not appear automatically as co-authors, even if a division head has actually written the manuscript and advised on the original experiment. So far as I'm concerned, this does not justify co-authorship. People merely carrying out a technical procedure used as part of the study are usually only acknowledged and not made co-authors. However, if the procedure was of importance, they should be offered the courtesy of co-authorship. Technicians are usually not co-authors unless they are senior, responsible for a major part of the work, or responsible for part of the design of the experiment. And always err on the side of generosity, even if a collaborator has been less than satisfactory in performance. Here's some words from another senior researcher. If a laboratory head gives approval to provide to another researcher a previously published strain of mouse that they themselves had obtained from a third party, they are entitled to accept authorship if it is offered by the leader of the team that receives the mice. This is a normal courtesy between laboratories. The WEHI guidelines, so this is referring to the 1991 guidelines, say scientific misconduct includes lack of appropriate acknowledgement of work primarily produced by a research student, trainee or associate. Therefore, if a student, trainee or associate is not the primary producer of the research, they do not need to be included as an author or be acknowledged. So part of these allude to what's called the Matthew effect. And I'll explain what the Matthew effect is. It was published back in 1968 by Robert Merton. Here's a picture of somebody at the Institute, and I just raised this because I used to have a whole collection of lookalikes at WEHI, and I'm thinking of re-establishing that. So if anybody has some interesting lookalikes, then send me the JPEGs, and I'll see if I can do that again. So Matthew, from the Bible, said, "For unto every one that hath shall be given, and he shall have abundance. But from him that hath not shall be taken away, even that which he hath." Right? So they're pretty hard-nosed in the Bible. Right? Put in less stately language, and so this is Robert Merton. The Matthew effect consists of the accruing of greater increments of recognition for particular scientific contributions to scientists of considerable repute, and the withholding of such recognition from scientists who have not yet made their mark. Now, this is something that's been recognised, since 1968, and it's something that still occurs today. So it's something that also is related to human nature, that journal editors and newspaper people will notice the big name. They'll notice the last author. They'll invite them to the meetings. They'll ask them for comments. They'll invite them to write reviews. Now, that's understandable and only natural, but it is something that we should try to fight against. We should try to make it so that those who contribute the most to a paper get the most recognition. One of the terms that often comes up when people are discussing issues of authorship are ghost and honorary authorship. So I'll just describe what they are. A ghost authorship is not authorship by writing down as an author somebody who's died. Ghost authorship is when some of the actual authors are not listed as authors, and this can be used to take credit for others' work, i.e., a form of plagiarism. But it's also used by the pharmaceutical companies to hide competing interests. And so this example from Merck is going to refer to instances of both ghost and honorary authorship. Merck employed ghostwriters to create journal articles that were favourable for the drug Vioxx, a COX-2 inhibitor. After writing the paper, so the paper was written using data from the company and written by ghostwriters that they employed, they recruited leaders in the field, or opinion leaders, to be the senior authors. For scientific review papers, Merck would outline the plan for the manuscript, then hire ghostwriters from medical publishing companies and typically pay them around $20,000 per submission to the ghostwriter. And the ghostwriter's name would never appear on the publication, either as an author or in the acknowledgements. And that way, Merck didn't necessarily had to include its name in the publication. The scientists then recruited to be the named author would then also be offered an honoraria for their participation. In a review in the Journal of the American Medical Association in 2008, where they looked at 96 papers published about Vioxx from Merck, that's a lot of papers. They found 90% of the papers on clinical trials disclosed Merck's financial support, but only half of the review articles disclosed Merck's sponsorship or involvement in the creation of a paper, or whether the authors were paid by them. Vioxx, as it turned out, was taken off the market in 2004 after it was linked to an increase in heart attacks and strokes. The FDA said it caused up to 139,000 heart attacks, 30 to 40% of them fatal. Merck paid $4.8 billion to settle the US cases and a further $1 billion in its legal costs. Australians who took Vioxx sued Merck and its Australian subsidiary. In documents submitted to the court, so this is an Australian court, it was revealed that Merck paid an undisclosed sum to Elsevier to produce several volumes of a publication that had the look of a peer-reviewed medical journal, but contained only reprinted or summarised articles, most of which presented data favourable to Merck products. this journal, and there were about half a dozen others. It's called the Australian Journal of Bone and Joint Medicine. It carried ads for Fosamax, a Merck drug for osteoporosis, and also for Vaux, and appeared to act solely as a marketing tool with no disclosure of company sponsorship. This is a picture of the edition of, I think there are only 2 editions of Bone and Joint Medicine. And if you look at the honorary editorial board, you can see that there's a lot of names of opinion leaders in Australia, including some from the Royal Melbourne Hospital and Melbourne University. However, there's nothing to say that they even knew their names were being used in this way. And some of these members of the honorary editorial board claim that not only were they not paid for this position, but they also were unaware of it, whereas some of the others, that was not the case. So once again, this illustrates why ghost authorship is wrong, because it fails to disclose potential conflicts of interest from the readers of the paper. So honouring ghost authorships, this is when someone listed as an author, even though they haven't contributed enough to justify authorship. So this is the opinion leaders that are included. It's used to claim undue credit, to curry favour with influential colleagues, and to influence editors, reviewers and readers. So who should be an author? The ICMJE, International Committee of Medical Journal Editors, recommends that authorship be based on the following 4 criteria: substantial contributions to the conception or design of the work, or acquisition, analysis or interpretation of the data for the work, and you'll note that I've highlighted some of the ors and ands because they vary depending on whose guidelines you're looking at. Drafting the work or revising it critically for important intellectual content, and final approval of the version to be published, and agreement to be accountable for all aspects of the work in ensuring that questions related to the accuracy or integrity of any part of the work are appropriately investigated and resolved. Now, this doesn't mention well, there's a relatively little mention of the people who actually do the work and generate the results. But you'll note that you can contribute either in conception or design, or in the acquisition, and I guess this is where generation of the data takes place, or in interpretation of the data, but you have to satisfy 1, 2, 3 and 4. These are the old WEHI guidelines from 1991, updated in 2002. Publication and authorship. The criteria for authorship: that each person listed as an author should have participated actively and significantly in the study. Now, I don't know how you participate passively, but this is what it says, and you have to do both. At its conception and or planning in a capacity other than simply generating the data. So the only mention of generating the data is in the kind of a negative way. But here there are ands instead of ors, and in its analysis, interpretation, and in the preparation and final drafting of the manuscript submitted for publication, and an author should be able to take public responsibility for at least the area of his/her expertise within the paper. So according to the old guidelines, if you hadn't been involved in the conception and planning and the analysis and the preparation and writing of the manuscript, then you couldn't be justified to be an author. And I believe that if this was adhered to strictly, there'd be quite a number of papers from WEHI that would have no authors whatsoever. Here's what's said by the NHMRC Australian Code for the Responsible Conduct of Research. To be named as an author, a researcher must have made a substantial scholarly contribution to the work and be able to take responsibility for at least part of the work they contributed. I think this is a much better guideline, although there are potential problems. So I think the key thing is you must have made a substantial scholarly contribution, and that can be in either problem solving, designing the work, generating the data, revising the manuscript, writing the paper, finding and correcting problems with the paper. It has to be substantial, and it's got to be some sort of intellectual or scholarly contribution. Now they add, and to take responsibility at least for part of the work they contributed. This, I think, is a little bit vague. What does it mean to be able to take responsibility? In what context is that referring to? Attribution of authorship depends to some extent on the discipline, but in all cases, authorship must be based on substantial contributions in a combination of, and here I've got that in blue because it doesn't say whether this is one or more. If it's only one of these things, is that a combination, or does that contradict what's set up the top? Anyway, in a combination of conception and design of the project, so you can't do one or the other, it's got to conceive it and design it, analysis and interpretation of the research data, drafting significant parts of the work critically or critically revising it so as to contribute to the interpretation. So my biggest problem here is that this part is a bit vague and this statement a combination of, because I think it should be either or any of those things. WEHI's current guidelines, authorship must be based on substantial intellectual contributions in conception and design of the project, or generating, analysing or interpreting research data, or in drafting significant parts of the work, or critically revising it so as to contribute to its interpretation. Right? So WEHI's guidelines say that if you do anything that's a substantial scholarly or intellectual contribution, then you should be offered authorship and you're justified in claiming authorship. Who should the ICMEJ talk about contributions? Contributors who meet fewer than the 4 of the guidelines I mentioned below, the criteria I mentioned above, should not be listed as authors, because they'd be ghost authors. But if they have contributed in some lesser way, they should be acknowledged, and I would say they must be acknowledged. Otherwise, it's ghost authorship. Examples of activities alone without other contributions that do not qualify a contributor for authorship are acquisition of funding, general supervision of a research group, or general administrative support and writing assistance, technical editing, language editing, and proofreading. Those whose contributions do not justify authorship may be, and I would say must be, acknowledged individually or together. Blah, blah, blah. So here's the old WEHI guidelines, 1991. Authors must ensure that the work of non-authors, including research assistants and technical officers, is properly acknowledged. Authorship is not justified solely by the collection of data or provision of materials. And here again, in the old guidelines, the few times that gathering data is mentioned, it's often in the negative, to say that it doesn't justify authorship. It does, however, say, in 1991, honorary authorship is unacceptable. The Australian Code for Responsible Conduct of Research, that says that authorship should not be offered to those who do not meet the requirements set out above. Those were the 4 things I showed you earlier, or substantial contributions, a combination of. For example, none of the following contributions in and of themselves justifies including a person as an author: being a head of department, holding other positions of authority, or personal friendship with the authors, providing a technical contribution but no other intellectual input into the project or publication, providing routine assistance in some aspects of the project, the acquisition of funding or general supervision of the research team, providing data that has already been published or materials obtained from third parties but with no other intellectual input. They also have a box where they list as an example of research misconduct, plagiarism and also misleading ascription of authorship. So the Australian Code treats this very seriously. It's interesting, in the United States, the Office for Research Integrity lists plagiarism as misconduct, but considers authorship disputes that fall short of plagiarism to not be part of their matter for consideration. WEHI's current guidelines, and again, if you do have suggestions for improvement of these guidelines, then come and see me, and if it seems reasonable, then we'll change them. Honorary authorship. Authorship should not be offered to those who have not met the requirements set out above. For example, none of the following contributions in and of themselves justifies inclusion as an author. And you'll notice some of the language is similar to the NHMRC language. We do refer to it in these guidelines, so we can't accuse us of plagiarism. Being head of a laboratory or division, or having a personal relationship with the authors, supervising a student, postdoc or research team, or holding other positions of authority, providing routine technical assistance or routine gathering of data, providing editing or minor corrections to a manuscript, acquiring or providing funding, providing data or materials that have already been published or materials obtained from third parties. Who must be offered authorship? According to the ICMEJ guidelines, anybody who's met all who meet the 4 criteria above. The criteria are not intended for use as a means to disqualify colleagues from authorship. So, for example, one of the ICMEJ criteria was drafting the manuscript, or final approval of the final manuscript. What this means is that if you hide that from one of the people who should be an author, hide the final version of the manuscript, you're not justified in saying, well, they shouldn't be an author because they haven't seen the final version of the manuscript, right? You can't use the criteria as a means to disqualify colleagues from authorship who otherwise meet the criteria. WEHI's current guidelines, inclusion of authors, all those who meet the criteria for authorship must be offered to be listed as an author, and all authors must consent to being listed. A person who qualifies as an author according to the criteria above must not be excluded as an author without their written permission, and if not listed as an author because they don't want to be, they must be named in the acknowledgements. Otherwise, it's ghost authorship, and that's not permitted. Authorship disputes with misconduct. I mentioned this before. The ORI doesn't consider authorship disputes to be something that it's interested in. WEHI Guidelines 1991. Scientific misconduct is defined as the standard fabrication, falsification, and plagiarism, but it also includes misleading ascription of authorship and lack of appropriate acknowledgement of work primarily produced by a research student, trainee, or associate, the definition of plagiarism, an act or instance of closely imitating the language or ideas of another without authorisation or the representation of that work as one's own, as by not crediting the original author. So it doesn't only apply to language, it also applies to ideas or intellectual property. Failure to list someone who fulfills the criteria for authorship is plagiarism. The current WEHI guidelines, misconduct, blah, 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 blah. It includes misleading ascription of authorship, avoiding authorship disputes. Now, so this bit is advice, and I have to admit that I don't always follow this advice, but I should, and I think it's something to keep in mind and to do so. The first one is keep good records. This means have your lab book signed regularly, keep all of your emails, keep copies of your records when you change labs, back up your records. This will help avoid authorship disputes. It will mean that if you are hardly done by, you can justify a change in the authorship listing. Negotiate authorship arrangements early. Maintain a list of author contributions and circulate it amongst the authors and potential authors when changes are made and when manuscripts are submitted. Err on the side of generosity. Use asterisks to indicate equal contributions, shared first, last author, etc. So nowadays, journals will often be happy to include lots of numbering and letters and asterisks to say that author number 3 and number 5 contributed equally, and so on and so forth. You must acknowledge those who aren't authors, but who have contributed in some way to the paper. It's worthwhile reading WEHI's guidelines because the authorship statements in WEHI's guidelines and advice is new. Keep good records, and I can't emphasise that enough. And many journals now do allow you or insist that you list the author contributions of all of the authors. And I think this will help reduce the number of authorship disputes where it's clear what everybody has done. Here's a recent paper from MD Anderson. And you can see this paper has 30 authors, and they're all got numbers and asterisks, and Cell now lists the author contributions. And you can see from the author contributions that AK, WY and HY designed everything, did all the work, all the in vitro work, wrote the paper, performed the model analysis, etc., etc. But the only 3 authors that have actually contributed, according to the guidelines, are the first one, the second one, the third one. So at least there's openness, and they declare what's going on. Allegations of concerns of possible research misconduct. So I've been involved with a lot of these things. After giving my 10 rules talks, lots of people would come up to me and say, this is what's going on in my institute, this is what's going on in another institute, and having acted, gone to the World Conferences on Research Integrity and other, one way or another, I've got involved with a lot of these cases. One in Canada, in Italy, United States, Canada, another one in Canada, Israel, and a number in Australia. And the thing is that most of you probably aren't aware that there are ongoing cases in many institutions throughout the country because most of them, the institutions and the journals manage to keep things very quiet. In most of these cases, I think in all of them, it's led to, I think, a couple of people have lost their jobs. There's been a few retractions, but in the great majority of cases, there haven't been any penalties at all, even though many of the cases appear to be serious, and even in cases where the investigations have determined that there's been intentional fabrication of data, that's not led to any actual penalties. I'm going to give some examples here, or one example here. This is some correspondence I've had with Michael Carron. Michael Carron has published over 500 papers, and 29 of them have been cited over 1,000 times. He's got an H factor of 190, and for those who haven't calculated H factors, that's big. He's ranked first worldwide by the ISI in a listing of most cited molecular biology and genetic research papers published in prestigious journals. When I was at La Trobe, I think it was James Vince came to me and said that there was something funny. He was looking at FLIP and said that they had trouble reproducing some of the findings in this paper. And so I had a look at some of the figures, and then I noticed there are a lot of anomalies, and I'll show them for. But in this figure here, there are these apparent duplications. So this is just to blow them up. This, to my mind, this band here looked very similar to this band over here, and yet there's no reason why they should be so similar. These two here look very similar, like the scratches here, the white ones, the black ones. It's probably hard to see with the contrast, but even the background pixelation is identical, and yet down the bottom it's different. These things here, again, they look too similar to just be coincidental. So, of course, I wrote to Dr. Carron. I said, "Dear Dr. Carron, in this publication, there appear to be duplicated bands in figure 2A, B and D," and I showed you those ones. "Could you please determine whether the published figures are a fair representation of the primary blots, and if they are not, determine who is responsible and whether there are other suspect image and papers, and take the necessary corrective action. Yours sincerely, David Vaux." So, and could you also reply to acknowledge receipt of this message? So I got a reply from him. He said, "As far as I can tell, I see no reason for this duplication, neither can I understand how it was done. We have already checked other allegations regarding this publication." So this was a surprise, but somebody else has seen problems with this paper and found them to be totally baseless, right? As far as I remember, each experiment was... However, due to her move from the lab and move within the same institute, the first author is no longer in possession of the primary data. So here there are a number of problems. First of all, how did they know it's totally baseless if they can't find the primary data? Secondly, why aren't they retaining the primary data? And again, keeping good records is vitally important to protect yourself and to maintain the integrity of the scientific record, because everybody makes mistakes, as well as there can also be false accusations. So keep primary data. Yet, as I've said, all of this has been examined and no data manipulations were found. Blah, blah, blah. And then a couple of days later, he sent me another letter. "Dr. Vaux, you may want to recheck your allegations. Please see Lu Feng Cheng's response, M. Carron." And then, so this is what Dr. Cheng wrote to Michael Carron. "Michael, please have them check carefully again the original PDF at high magnification in the circle," and I've copied those things below, right? So they wrote, in figure 2A, the band in lane 1 appeared to be a little bit wider than the one in the other lane, right? So this obviously can't be, this must be a coincidence. In figure 2B, the pattern at the bottom of the bands clearly demonstrates they are from two separate samples, right? Whereas, how do you explain this? I mean, the easy explanation is obvious. You just Photoshop the bottom differently to the top. No idea why they circulated lane S1 and 2 in figure 2D blotted by FAD, right? No idea why they circulated this, right? And of course, Michael Carron forwarded that on to me because he believes his postdoc, but doesn't actually look at the data. So I was incensed by this, because if I write to somebody and raise this sort of issue, and I know that if somebody writes to me and raises this sort of issue, then I feel physically sick. That's the normal response of someone when somebody raises questions about the integrity of your work. But Michael Carron just seemed to be very blasé. Anyway, I wrote to John Dahlberg, who's the Director of the Division of Investigative Oversight at the Office of Research Integrity in the States. He replied to me, "Hello, David. Thank you for sending us additional allegations." because I hadn't sent them before. We have been working with UCSD on this matter, but you have added additional concerns about this paper. So when Michael Karen wrote back to me saying that you've raised additional allegations, that's because somebody else had raised them, that they were being investigated by UCSD, and it was known by the ORI, right? So what happened? Nothing, right? So these papers are still there. There's been no retractions, no corrections. That's how it is. And there's a whole bunch of other papers with similar anomalous appearances in other papers from the same lab. Indeed, there's a new website called PubPeer where you can search on papers and look to see if people have raised suspicions about the data in those papers. And this is one raised about the same paper in Cell, in PubPeer, and you can see that in figure 3D and 4A, even though these cells are meant to be treated differently, it's exactly the same 4 panels in the fluorescence image. And even the knockout mice, these are supposed to be wild type, this is supposed to be double knockout, but if you look at the embryo, it's exactly the same. And yet, you know, neither UCSD nor the Office for Research Integrity found that there was anything that needed correction in that paper. So, handling concerns of possible research misconduct at WEHI. In general, one way of doing it is by establishing principles and appealing to ethics. This is the speed limit model. So this is the idea that you say what you should do, like you shouldn't go above 100 kilometres an hour in your car. You put up a lot of signposts. But the problem with this model is that if you don't have a police force, if you don't have any speed cameras, then everybody's going to speed. So this is a nice idea, but I don't think this is a valid way in total of handling research misconduct. Another suggestion is that we need to educate people and just tell them what should be done, what is the right thing to do. There was a study done at the University of Minnesota where they had a whole bunch of new students. They did anonymous surveys to begin with to ask them what they knew about misconduct, what they would do in certain circumstances to work out how basically honest they were. And then they gave them the lecture talking about research integrity. Then they resat the questionnaire, and they found that after attending the education session, they became less honest. And that's because they became aware that everybody else was cheating, and so that there was an incentive, and they'd learnt the techniques to do it themselves. So I don't think education in and of itself is going to be a panacea. There's the police and surveillance model. That's where you install cameras in the corner of each of the labs and in the corner of all of the offices, and then you record everyone, and then at random intervals there's a flying Gestapo squad that comes in and looks at everything you've done. So I think there'd be relatively little happiness with this sort of model. The model that we adopt at WEHI is sometimes known as the fire alarm model. It's the same model that the fire brigade works under, and that's that you don't have to tell everybody, you know, all of the detail. They don't have to memorise the Australian code. You just have to trust that people will, if they see something that worries them, you have to provide them with an alarm, a button that they can press to get more information, to find out what should be done, to learn about the procedures for that they can go through, and to get advice. There's this diagram that's in the WEHI guidelines. If a concern is raised by somebody from within WEHI, or if you have a concern, you can raise it directly with the designated person, or you can talk to one of WEHI's integrity advisors, and so they're listed in the guidelines and on the web. And they will tell you what are the pitfalls of acting as a whistleblower. How do you raise concerns? Do you have to reveal your name or not? If you decide to, then you can formally raise an allegation with the designated person. I'm the designated person at WEHI, but we have a number of alternative designated people, because there are cases where I'll be conflicted with the person who's raising an allegation or the person who the allegations are against. If a concern is raised from outside WEHI, from a scientist reading a paper from WEHI, or from an editor, or from the NHMRC, etc., then they can find out who I am by looking at WEHI's website, and they can raise those things with me. What the role of the designated person is to carry out enough investigations to determine with a high degree of confidence whether the concerns can be dismissed or not. and that may or may not involve contacting the accused person. If the accused person is going to be told that somebody's made allegations about them, then they'll be given the name of somebody who they can contact to get advice from and can offer them support as well. Because being accused of research misconduct is one of the most stressful things you can possibly imagine. If the designated person is sure that the concerns can be dismissed, then he advises the director, and the director will report to the complainants and the funding bodies to say that there's been a case that it's been found not to have prima facie evidence and that it's been dismissed. On the other hand, if the designated person cannot dismiss the concerns, then he advises the director that an internal or external inquiry should be carried out. I think in most cases where it's a serious concern that might involve somebody losing a job or somebody retracting a paper, then an internal investigation would definitely have some members who are from outside WEHI, and ideally we'd like to have all of the members of the panel from outside WEHI. But that's the decision of the director. If an investigation is to be carried out, then an integrity advisor will be appointed, if there hasn't been one already appointed, to give advice and support to the person who's been accused. The panel's main task is to confirm or refute the allegation. They may obtain evidence, advice, and conduct interviews, right? So they have the power to seize all records, email, correspondence, all of the primary data, the blots, and so on, and they have to secure them so that they can't be tampered with. If they find evidence of scientific misconduct, they will expand their investigations to determine its full extent and who is responsible. So if they find dodgy blots in one paper, then they should go and look at all of the papers by all of the authors to see if it's a pattern of behaviour. And to find out who's responsible, they have to interview all of the authors on those papers. They will then determine the full extent of misconduct, if there is misconduct, and who is responsible. They'll present their evidence to the accused person and allow them to challenge it. The investigatory committee advises the director of their findings of fact, and then the director decides if misconduct has occurred based on their advice and determines the appropriate remedial action, which may include correcting or retracting publications and or imposing penalties. The director will inform the relevant funding bodies. So it's important to realise that there's a spectrum of research misconduct. Some of it is extremely mild, like intentionally failing to cite your competitors or self-citing your own papers more often than you should. You could argue that doesn't even really fall into the category of scientific misconduct. It goes all of the way to the other extreme, which is behaviours or procedures that may endanger patients or lead to mistreatment of animals, etc. Some of them can even be criminal if it's embezzling funds and so forth. So it's appropriate that that any remedial action is appropriate, that it corrects the record as well as takes care of integrity of the researchers themselves. Advisors will tell people who come to them with concerns that if the allegations are substantiated, the motives of the accuser are irrelevant. Allegations will be considered separately from the character, position or reputation of the person who brings them. It is not a responsibility of the accuser to obtain all the evidence, to prosecute the case, or to provide the burden of proof. That's the job of the investigation. For some allegations, e.g. data fabrication, is not necessary, or it may not be necessary to reveal the identity of the accuser. The evidence may stand on its own, whereas for the others, e.g. authorship disputes, it may be necessary. The accuser will be protected from retribution, and as people have a duty to report concerns of possible misconduct, there will be no penalties or criticism of the accuser unless the accusations are found to be both unsubstantiated and made in bad faith, i.e. knowingly and dishonestly, or known to be dishonest. Advisors will tell people who have made allegations against them that errors need to be corrected whether they are intentional or not. And so if the person who's made the error demonstrates goodwill by retracting the paper, by correcting the paper, then that will be seen favourably. Misconduct is a spectrum, as I said, from the trivial to the extremely serious. The seriousness of the penalty or sanction will be proportionate and will vary according to intent, frequency and the type of breach, and will run from just some counselling and words to dismissal or referral to the police. Anyone accused is entitled to see the evidence against them and to defend themselves. Willingness to correct the record, publishing corrections or retractions will be viewed favourably. Allegations of possible research misconduct. The responsibilities are not only to the accuser and the accused, but also there are responsibilities for the safety of personnel, for patients and animals. So in some cases, even before the investigatory panel has completed its findings, it may be necessary to halt a clinical trial. It may be necessary to remove a researcher, or animals from a researcher. There's also a responsibility to the integrity of the scientific record. Even if there's no misconduct, if there are unintentional errors, the scientific record still needs to be corrected. And it's important that these things are done in a timely manner. So there's a tendency for investigations to drag on. You know, there are some in Australia that have gone on for more than 4 years and yet still not come to a definitive conclusion. And yet none of the papers that clearly need to be corrected have been corrected. There's also a responsibility to the research community in general, so that they have confidence in research as a career, responsibility to funders who provide the money. The penalties need to be proportional. Correcting the record or alerting relevant parties does not have to happen at the same time as the penalties or punishments. And the best protection and prevention is good records. Support and advice are needed for both the accuser and the accused, and Australia needs an ombudsman or an ORI. And again, I'm on my hobby horse, but the United States and many civilised countries have offices for research integrity or ombudsman. Australia does not. They're not a panacea. The ORI in the States has a lot of shortcomings, problems with funding. It has problems with not looking at authorship disputes, not looking at things more than 5 years old. But we need an ombudsman or an ORI to provide advice to institutions, to advice to people on how to make allegations, to collect data, to improve the Australian code, and so on and so forth. WEHI's policy and procedures are neither fixed nor perfect, so feedback is welcome. And I'll end there and ask for some feedback. Chris.
I'm going to ask the first question.
Overall.
If you're sitting, one of the ways to prevent this is by looking and discussing primary data, being open to discussions. If you're an undergrad student, an honours student or a PhD student, you're in a lab meeting and you see something that you maybe don't understand, you're worried, the error bars look too small, how would you raise that in a way that, that's a difficult conversation to have with anybody. I absolutely agree with you that they're conversations we should be having all the time. How do you start that conversation without it being initially an accusation, without it being a big deal? Because they should be commonplace.
Yeah, so this is something that it's hard to write into guidelines, but I think WEHI does a lot of these things right, or at least the labs I know about. So, for example, it's best if primary data is shown rather than all labelled and glossy and cropped, PowerPoint presentations. So, I'd encourage labs that don't have them to have an overhead projector so you can show an order rad. It's important that lab meetings are regular and that everybody's encouraged to make comments and to ask questions about each of the slides. And again, WEHI has a good tradition of asking questions during seminars, Wednesday seminars, but also lab and divisional seminars. So that needs to be encouraged. There also needs to be examples set. So examples set by the senior people to interrupt people, to ask questions, but to point out what are your error bars? How do you know that this is significantly different from that? those things look very similar. You know, can you go back and check your original data? So I think leading by example. Again, it's hard to put it into a guideline.
Who would you talk to first? Would it be your lab head or the person?
Well, I think that, you know, I think yes, I would. I think the thing is, as soon as you see it, to just say, you know, that looks a bit funny, right? So whether it's, you know, you see something on the bench or in an office or in a lab meeting, to just raise it, because these meetings should be places where you can openly criticise without making accusations. Because, you know, it is true that people do accidentally include the same fax profile twice, because all fax profiles look the same. You know, saying, you know, act and blot, they all look the same.
It's really asking for a clarification first, because there's something you don't quite get, rather than it being a big deal.
Yeah. So the point is to speak up, and speak up early, rather than letting it worry or speaking it up and not addressing it to the other person.
And from a director's viewpoint, that is a far, far better outcome than somebody phoning the director, as I've had happen, saying, I think there is paper X at the institute or at the university, and then going to a lab and saying, why wasn't this picked up? And somebody saying, well, I saw this 3 years ago, but didn't say anything. So from the viewpoint of how you will be regarded by senior colleagues, much, much better to raise the issue when it's a small issue, and maybe somebody's inexperienced, or as Dave said, has cut and pasted something in the wrong place. Much better to deal with it as a run-of-the-mill sort of thing than have to deal with it as an institution when the shit hits the fan.
I was just curious if anyone's actually done any studies into the direct and indirect costs of misconduct in science.
I don't know one off the top of my head, but it wouldn't surprise me. But if you look, there's some work done by a guy called Ferric Fang, it's an excellent name, and he's done some studies looking at you know, the causes of misconduct, and I think he might have also looked at the costs. But you know, if you look at you know, Glenn Begley's paper, and there are a couple of others from companies looking at the amount of money wasted by, you know, by Pfizer and by Glaxo and by Merck. You know, Merck obviously wasted, you know, $6 billion on something that was caused by misconduct. Novartis has had a similar problem in Japan with a blood pressure medication. So, you know, it's big bucks.
Let alone the 65,000 people that died because of the...
Indeed.
Marnie?
So I think in other industries, maybe like financial services, or for example, if their ombudsmen are paid for by the banks, which doesn't make a lot of sense, because then obviously it costs them money to have something go through their ombudsman. So how should we fund an ombudsman in Australia?
Well, I don't think we should, but I think the government should fund it. So the ORI in the States is mandated by Congress, right, directly by Congress. So they're separated from the NIH. So you know, we should have something like that here. We should have the Parliament, you know, or government sets up an independent office or commission. It doesn't have to be an expensive one, right? You know, so in Germany, for example, they have an ombudsman as just one sort of person, a couple of part-time assistants, and they don't investigate everything, but they provide oversight. They check that the universities are carrying out. You know, they look at their reports and they see if it all looks kosher or not. They make sure that any allegation that's investigated by a university is also registered with them, and they'll refer things on back to the university. So it doesn't have to be complicated, but it does provide an extra layer of oversight and objectivity.
So I was always very unhappy with WEHI's authorship guidelines, because I was certain, like you, that, you know, almost no one ever qualified.
Yep.
And I'm glad to see that they're much more sensible now. But a related issue is patent inventorship, and those rules are still seem to me to be much more aligned to the old, much stricter rules, and they have legal and financial implications if you get them wrong. So what's your advice about, I guess, WEHI staff looking at the authorship of the paper and then looking at the inventorship? I mean, how can we harmonise that or minimise the damage associated with the discrepancies there?
I don't know. I guess if I'd talk to Julian Clark, I guess, and
so
but
maybe I could comment on that. So as you know, Nick, generosity in many ways has no place on inventorship because we're going to be legally challenged by competitors that may want to sink the patent. But I think there is an element where we look at that in two ways, and I think we could go a step further. The way we're looking at it, that we looked at previously, is to share some of the royalties with everybody to make sure that there is an element, for those of you that don't know, 20% of the commercial income that the Institute makes gets spread evenly among all staff and students that have been here for a year or more, so once you've stayed a year. So that's one way, but a small way of mitigating it. And I would argue that something we could look at, and I'm happy to take to the Board Commercialisation Committee, especially as research has been done by larger teams, is to find some better way of rewarding a team that has contributed to a research outcome rather than just inventors. And I think that would be something that we could look at. But I don't think they're ever going to be harmonised because they're based on very different things. I'm happy to keep going and take more questions. Obviously it's 2 o'clock. I have to go in 6 minutes because I'm being interviewed to see whether I have a job still. That's an important meeting in town, for me at least. I'd be happy to go for a few more minutes and then maybe the lady in the beret whose name I don't know.
Hi. I can imagine your guidelines are particularly tricky when it comes to a very famous medical expert, say, with a BMed student who comes up with quite original ideas and does all the work. And I've heard very painful stories about that, not going very well. Having heard the discussion, I still think it's a very grey area as to how that would be.
So to my mind, it's clear. If they've made a substantial input, right, and it's substantial just means more than zero. It means, they can demonstrate that they've made an intellectual contribution, then they should be an author, right? Now, I do note that in our guidelines, we've still got the word primarily. I'm going to remove the word primarily from that, from the guidelines. You don't, the student or a trainee doesn't have to be the one who's primarily provided the input. They just have to have provided some input and they should be an author.
Well, in this particular case, I'm thinking of they provided sort of 8% and
Yeah.
the professor took like 98% of the credit.
Yeah, but were they listed as an author?
Very far down the list.
Yeah, well, so again, you can argue about position, and nowadays, of course, in many journals you have to list what the actual contribution was, and that should make it clearer.
Look, the power discrepancy is perennially going to be a problem, and I think what you would hope to have as an institution is enough sympathetic senior people to whom that BMed student could come and discuss the issue. I don't think it is ever possible to clarify every possible permutation and combination of contributions to papers and mandate authorship orders, but you want a culture where that can be discussed without retribution and seen to be a healthy part of science.
But for the BMed side,
absolutely,
for the BMed side person to make their case, they need to keep good records, so they can say this is the draft. These are all my inputs into the draft. This is what I've done. And the same is true for the senior person. If they can say, look, here's where I've given them the guidelines and the thing, and set them all out and so on, then that will protect them.
I think the problem was the culture. It wasn't
right.
No.
If it was, you can come and talk to me. One of the things that we don't do well, and has been an issue previously in an inventorship case, is keeping in our laboratory notebooks the records of ideas versus the records of data. So if you're a lawyer, you're trained to keep a day book where you're noting down ideas that you've had, or more often clients you build for 5 minutes of work. It's worth considering that recording of ideas, especially if you're working in a project where there's commercial collaboration.
You showed quite a few examples, and they are pretty much of a lot of the big journals that all scientists would like to publish once. Is there any action in place in those big journals nowadays to spot on those problems before they go out to publication?
No.
Thank you, David.
I'll see you later.
Cheers.
Don't see me tomorrow. It's me again.
No, so Michael Cameron, for example, is on the editorial board of Cell. And so, no.
So, as students of the University of Melbourne, I think also as honorary appointments of faculty are actually also bound by the regulations of the University of Melbourne. Even we found
We have the Melbourne University integrity people over there, so...
Yeah, so the University of Melbourne has a website, Academic Honesty, in one way that describes their regulations, and we are bound by those regulations as well as by any.
Yeah, so it can be tricky in that, you know, there's also we're meant to be bound by the Australian Code and Melbourne University and by WEHIs, and they're not always the same. So again, you know, use your own judgment. They all have their intent in the same direction.
Dave, can I just add something? A better place to look for advice about the university's guidelines, the Office for Independence and Integrity website, rather than the Academic Honesty website. The other advantage that we get to share is that the university has an additional 20 research integrity advisors, aside to the ones that we hire, that you're able to contact for advice. So if something that you're concerned about is way too big and it involves Dave and Doug, then you can come and speak to someone over the road who'll be able to provide you some advice and probably put you in a witness protection program.
All right, we'll leave it there. Thank you.